Hello everyone, my name is Farhat and I would like to welcome you to just this amazing insight session, yet another amazing insight session that we are going to be talking today together with Ultraleap and our friends from Ultraleap here. The main title of today's session is how to enable intuitive interaction in VR and XR with hand tracking, and specifically how to utilize those. But before we jump into the webinar, I would like to remind you that throughout the webinar you can submit your questions at any time in the Q&A session. Please use the Q&A tool that is in your Zoom application. Shoot your questions at any time, and we will answer them in the end whenever we have time. And whoever feels confident will jump in and answer the questions. And if we can't find enough time to answer your questions, we will publish a blog post to answer, and you will get the answers in the blog post. But before we start, let me quickly give you a brief intro about Varjo. Varjo creates enterprise-grade photorealistic, virtual, and mixed reality hardware and software. And we have offices in Finland, USA, and Norway, and moving even more. And we are currently setting up to more than 40 markets in the world. And as a unique feature, of course, you'll probably all know, we have the video pass-through mixed reality, blending real and virtual seamlessly. And we recently launched the world's first human eye resolution VR and XR streaming platform called Varjo Reality Cloud. And of course, all of these are happening with the highest resolution, highest possible resolution, which at Varjo we call human eye resolution, with 115 degrees field of view and advanced eye tracking, which is also integrated and running at 200 Hertz. And today's most important topic was the world-class integrated Ultraleap Gemini hand tracking, which we will go deeper now in a minute. With these amazing hosts which are here together with me today, I introduced myself already, and Jussi can continue from this point on.
Okay. Hello, my name is Jussi Karhu. I'm a software engineer here at Varjo. I'm looking after our engine integrations for Unity and Unreal Engine.
Hi, I'm Kemi Jacobs, a QA engineer in our tracking engineering team at Ultraleap.
And I am Chris Burgess. I'm the product manager for all our XR products at Ultraleap.
And I am Max Palmer. I'm a software architect in the XR team at Ultraleap.
Yes, thank you. It's super awesome to see you here at Varjo, and I'm super excited about the webinar that we're going to have today. Before we then jump into the depth of it, maybe Chris, you could give a short intro into Ultraleap.
Sure, thank you. So from Ultraleap's side, we want to make a big impact on the way that people are interacting in a digital space. So we believe there's a future where there's no controllers, no wearables, no touchscreens, just natural interaction. So today we're going to go into that in a lot more detail. And we're going to see how exactly we're going to power that future of natural interaction. So first things first, we are trying to get this world where controllers are no longer relevant. In XR, it's hugely important, especially in AR, where you can see your hands. Being able to hold controllers just isn't the right sort of input method. But also in VR, being able to take away that learning curve of trying to learn what all the buttons do, how you're supposed to use them. Being able to use hand tracking really reduces that learning curve.
And in relation to Varjo, so Varjo VR3 and XR3 headsets have the integrated Ultraleap module, which you can maybe a little bit elaborate on that.
They do. So at Ultraleap, we actually provide sensors that can be integrated into hardware. So within the VR3 and the XR3, we've got our sensors kind of integrated. And what that can do is capture data based on the position, orientation, and the velocity of the hands. So what that enables us to do is to generate real hands within an experience, and that will allow for this natural interaction. So the more accurate we can get that data, the more accurate the actual digital representation of the hand will work inside the experience.
And in the video on the slide that we see here, the video on the left is what the user of a Varjo XR3 is seeing in his eyes. And then at the same time on the right-hand side, this is how it could be translated into VRC.
Yeah, and I think that's the key thing here is that it's both works in AR and in VR. And so here, like I say, being able to see your real world hands are so important, being able to interact with them.
And let's see some more. How does it actually work?
Yeah, that's a good question. So here we've got all that data that we're taking about the velocity, the movement of the hand. We're actually we use that data to be able to drive digital versions of the hand. So here we've got a robot hand, but you can actually customize lots of different kinds of hands, which Max will touch on a lot later on with his kind of deep dive. But this is a good way of at least demonstrating what I've been trying to get across here. You know, you can see these hands are being driven by this real world hands.
So I move my hands like this, and then that's what I see in the virtual
Exactly
environment
that,
or
yeah.
in the real extended reality environment. Excellent. Chris, you mentioned the hands as controllers. We have a video that we can share with our guests here. So this is a video showcasing an XR3 user interacting with the VR environment. As you see, you can see his hands over there, and he's able to manipulate the objects in VR and use certain gestures and even draw with a pinch gesture, for example, particularly over here, or even grab things that are in VR.
Yeah, I think what this does is it brings together everything. So on the one side, we're talking about natural interaction, which you can see with picking up cubes as they would expect to in the real world. But there's also intuitive interaction. So if you see they pinch together their fingers to draw with paint, and you've got a hand menu. So that's how do you bring in kind of ways that lower that barrier to entry for a user that hasn't come into VR before in a way that actually, you know, they're not familiar with having a menu attached to their hand. But being able to introduce that in ways that make sense to them is hugely important, and this is a great example of exactly that.
Yeah, definitely. Like as a technology, it's super cool. But then, how does it translate into the value that it brings to the different XR markets, different industries, for example?
So, hand tracking kind of works in any environment where you've got VR or XR. But here's some good examples from our side. So we've got training. You can use that as a way of getting new users for VR to learn a particular procedure. So maybe training a barista on how to make coffee. Got design reviews, so being able to actually pick up and manipulate objects that you actually want people to investigate. We'll come on to some examples of that later. Education, you know, being used in the classroom. Healthcare and medical, so being able to pick up surgical knives and actually be able to use them, but with your hands is very important. Industrial, being able to use them to actually operate machinery and doing that kind of thing. Retail, being able to determine how you should lay out a store, for example. You might be able to use hand tracking to determine where the best place of positioning things are within a real world. And then finally, even within theme parks is a really good example as well. So being able to have users where you've got limited amount of time to kind of bring them through an experience. Using hand tracking means that there's that low barrier to entry. It's quick to learn. You know, it's a great tool for using in that use case.
Yeah, it definitely makes so much sense. You mentioned about the design reviews. Maybe Jussi can briefly tell us a bit about how it could be used in design review.
Yes, excellent. So what you see here is the software called Autodesk VRED. And for those of you who are not familiar with VRED, VRED is basically probably the most commonly used 3D visualization software, especially in the automotive industry. And it's usually used for things like design reviews. And these sessions, design review sessions, they are often joined by like a lot of like non-technical folks. Like they don't know how all this technical stuff actually works. So what they do, they bring in like a CEO of a big automotive company in the room, and they put them with a Varjo XR3 headset, for example, and so okay, here's the latest designs for the next year's lineup, and let them like look around in the scene. So obviously these C-level executives, they don't necessarily want or know how to use the motion controllers and which buttons they need to press to do something in there. But what you can see here in the video, we have this what's called a configurator. So they will see, when they enter the application, they will see their real hands rendered there. And when they bring up their left hand, they can see this configurator coming up. And there they can basically use it just like it was a tablet or something, something that they can just use their fingers to poke and try different configurations, different colors, and how does it look like if the doors are open and so on. So basically, this is all about like lowering the like the barrier entry, what Chris mentioned earlier. So bring people who don't need to learn how to use controllers.
Yeah, and I think the key thing there, you alluded to there, was the almost bringing a tablet-like display in there. So there's, whilst it's attached to the hand, there's that connection between something they're already familiar with. So it actually makes it a lot easier to use and learn how to use. So that's a big part of it being intuitive.
Yeah, definitely, because like right now I have a tablet over here and it's just like quite intuitive for me to use it. Right. So yeah, we've seen a couple of good examples. But then what makes the world's most advanced hand tracking system possible? Like what are the key components?
That is a real good question for it. So essentially, it's kind of three components. So let's start from the hardware. So we're obviously integrated into Varjo's headsets. So the XR3 and the VR3. And as Varjo had mentioned earlier, you've got that ultra-wide field of view, 115 degrees. And then the sensors within that are based on infrared technology, which essentially just means that the camera view, we can get reliable hand data, even in difficult situations. So then if you build up on top of that, we go from hardware to software. So the headsets have got our 5th generation of hand tracking. And obviously one of our really good features is the fast initialization. And then we're obviously really robust to complex backgrounds and two-handed use cases. And so it's like, from that example that we saw with VRED, essentially being able to kind of use one hand as a menu and then using the other selecting is like a really good use case for us in being able to do two-handed interactions. And then once you build up on top of those two things, we then go into our developer tooling. So we've got developer tools for Unity and Unreal that people can use, and Max will go into that a little bit later. We're OpenXR compliant, because obviously there's a lot of things there that help developers. And then we've also really tried to look at our guidelines in terms of being able to assist people who are like, okay, how do I get started into hand tracking? How can I do this? So we've got a lot of information on our website about how to start your development.
So you mentioned the 5th generation, so there must be 4 generations before. So let's have a look a bit deeper on the 5th generation. What are the unique features of the 5th Ultraleap Gemini?
Yeah, so we've got a couple of features that we obviously really want to say that makes our hand tracking the best in the world. So, well, actually, as you can see from the video, we've got this part about like two-handed interactions, and I'm definitely a person that talks with my hands. And as you can see, it lets you like interact naturally, and especially even if like one hand is like partially obscured, we work really well with that, and that kind of brings back the art studio demo that we saw, where someone was able to interact with different objects and obviously kind of use like one hand to teleport across the application. We're robust for different hand anatomy. I mean, obviously, diversity within people. We want to be able to work for everyone, and that's like really one of our good features. And as I previously mentioned, the fast initialization, because it's essentially like the minute you kind of bring up your hands in a VR or XR application, you want to be like the tracking follows you at exactly the same time, so that it feels intuitive and natural. And we also work with different lighting conditions and just like cluttered backgrounds. So obviously, if someone's got a Varjo headset, they could be working in a home environment or maybe within the company, or even if it's kind of like mixed reality, maybe they've got things that are like out and about. And so you want to be able to cover all those kind of different situations and conditions.
Yeah, that sounds super ultra high leap technology. On the video over the right hand side here, that we see the infrared cameras seeing the hands of the user from the headset, and the detected bones are overlaid on top of the infrared camera view, which we can then maybe talk a little bit more what makes the infrared to be the best to use in this kind of context.
Yes. Yeah, so currently in the Varjo headsets, we're using infrared cameras. And essentially, you can kind of see with those two photos, with the IR illumination, we get like good lighting for the hand, which then means we just have like the best images to be able to bring out our hand tracking. And then obviously that can then be used in different use cases for customers or users. So obviously infrared is like invisible to human eye, but it takes out a lot of the visible light, and so that's why you end up with more illumination there. And a lot of the technology there is patented within the company, and we just basically use an IR filter to produce like a really clean image. And as I've kind of said before, it just means that depending, it can work in different backgrounds, or even if like the hands are moving very quickly within a scene. So yeah.
I think the key thing is that you don't have to have a very controlled environment to be able to use it. So it means, to that point, you could have a very busy carpet, for example, or a really dark room, and you shouldn't have to worry about that. Hand tracking will still work. And I think that's the key here. It still works.
Exactly.
Yeah, definitely. How about then if I'm inside a virtual cockpit?
Good question. I think to kind of bring up everything that Kemi's been saying, this is a really good use case for us to show the accuracy. So here within a pilot situation, you've got really small buttons that you're trying to interact with. And in order to be able to interact with those things, you need very accurate hand tracking. And here, our hand tracking really suits this exact use case. And you can see a number of things we've already talked about here as well. With like custom hands, you can actually have a pilot's gloves here. There's a few good features within this experience, but the main thing it really highlights is that accuracy.
Yeah, all sounds super cool and super exciting. But then, as a developer, me or other developers out there, how can they make use of this amazing technology and integrate into their applications?
Yeah, that's a really good question. Hopefully most of you are thinking it right now. So yeah, we offer plugins for common XR platforms. So Unity and Unreal cover most of that. And yeah, we have plugins available for them. We also support OpenXR, and we think that's something that's really important. And I know Varjo is on board with that as well. And MRTK, third-party frameworks also integrate hand tracking. It's fair to say that the tooling we offer for Unreal and Unity, we try and keep feature parity, and we have things like core hand tracking components, interaction engine, which is for interacting with physical objects, and then also things like the hands module, which is for making custom hands, and we'll talk more about all of these things. If none of that is good enough, right, we've got a native SDK, so you can go down to the LeapC API, and that gets you to really close to the kind of low-level APIs. You can do stuff there.
That's great. Yeah, so I'm of course familiar with your fantastic developer offerings for Unity and Unreal, especially. But can you walk us through, Max, like how would one actually go through and like create a VR process from scratch and add hand tracking support for it?
Absolutely. So that's a great question, and my message is it's really quick and easy to get going into hand tracking. Our components ship with kind of blueprints and prefabs that allow you to sort of get going and examples. So let's see how we do that in Unity, and what I say for Unity will also apply for Unreal as well. So let's look at how we get going with the Varjo and Ultraleap plugins. So here we're installing the Varjo plugin from a Git URL, and all of this is available on the documentation on Varjo's website. And we just wait for Unity and the package manager to bring that in. It goes out, talks to the Git repo, and then just pulls in the plugin. And that should take a kind of couple of seconds for it to come in.
Getting there.
It's in there, yeah. It's near real time. And so then we have to bring in the Ultraleap plugin. And our way of recommending that is to use the package manager and create a scoped registry. And that goes out to something called OpenUPM, which is a repository for packages. So we've done that, and then we go back into the package manager and we look at the My Registry section, and we will see, hey presto, there's the Ultraleap tracking plugin. So you can import that into Unity, and it will do its magic and start to bring the plugin in. Yeah.
Yeah, the same process again.
Yeah, same process.
Getting there.
I think the important thing to mention there is that we're trying to fit within common Unity workflows. So the package manager is definitely something that increasingly developers are starting to adopt. So we've fitted within that. So it's quite, hopefully just working well for developers without them having to kind of learn a new process.
Yeah, and here we've just seen, I've made a little tweak to the camera so that you remove the clipping plane, because you might bring hands in really close and you don't want them to be clipped. And then we're going to look at the prefabs in the core kind of part of our plugin. So I've added an XR provider, which is a key source of hand tracking data, and it's kind of fundamental to the way the Unity plugin works. I've added some hand modules, which are our capsule hands, and now I've got to set up the offsets. So it's really vital that the offsets between the kind of tracking camera and the head pose of the headset are set up correctly. So there's some sample code I'm just adding from Varjo developer website, and that just says, based on the headset type, what are the offsets that we should be using, and that gets perfect alignment for kind of hand movements and head movements. So that's all set up, and those prefabs are in, the scripts is on, and hey presto, we have these things called capture hands in the scene.
That's super impressive how easy it is to actually create a project from scratch and just add hand tracking support for it. Yeah. So it's not really that more difficult for Unreal either.
No.
So yeah, for the Varjo specific device specific offsets, just go to developer.varjo.com and select the engine of your choice and navigate to the hand tracking page, and you can find the instructions here. And for everything else, you can just follow the official Ultraleap documentation. But tell me, Max, like we saw here the iconic capsule hands that every Ultraleap developer knows very well. But how would one go about doing something that looks actually more like real hands?
Yeah, that's great. Yeah, I mean everybody knows the Ultraleap hands. They're kind of they are iconic, right? But you might not want to look at them all the time. So we provide kind of several rigged hands based on meshes, so meshes that have been rigged so that they can be driven by the hand tracking data. And they're in our kind of prefabs or blueprints in Unreal. And models often come with arms, because one of the kind of super cool things that we do is we track the elbow as well, and so therefore we can get the motion of the forearm, and that's kind of vital for kind of avatar experiences, so social interactions, seeing just your hands but seeing the forearm is really great, and maybe if you're making gestures and pointing, you've got the kind of axis of your arm that you can point along. But if the kind of hands that we provide in the prefabs don't really work for you and you've got your own hand models, we also provide tooling to make it super easy to kind of bring in other models, your own models that are hopefully set up to some conventions, and get them going in your kind of application. So let's have a look at how you would do that. So yeah, we're setting up the scene again. We've got that service provider that I said is integral to the kind of whole kind of hand tracking experience and data flow. And this time we've gone into the hands section of the Ultraleap tracking, and we're looking at bringing the ghost hands in. So that's another kind of prefab. It doesn't have to sit below the service provider, but I've just set it up that way. And then we see the two hands that are in there. There's some cool features of the mesh hands that we've added recently, which allow you to scale the mesh to the real data, so trying to estimate the hand size, and that's really important for things like AR as well. So yeah, there we go. We've got the kind of mesh hands, or ghost hands rather, up and running. And that was just like we were adding the capture hands, super easy. Another great thing that we offer in our tooling is examples. So you can find them in the package manager, and there's some examples for several things that I'll talk about in a minute, kind of interaction engine and other things. But one thing we're going to do is we're going to open actually a desktop example which shows the different rigged hands, and take a look at what they look like in a second. So yeah, the examples are just coming in. And then we'll go to the scenes in the project, and now we've got a whole load of examples in there, including desktop hands for rigged hands.
These are quite many sample scenes there.
Yeah, there are lots of examples for lots of different things, and hopefully we cover most of the kind of use cases that you've got. So we've opened that up, ignore the TextMesh Pro importer issue. So if we run that, we can then use the cursor keys on the keyboard, and we can cycle through the different hands there. So we offer kind of the low poly hands, which might be good for performance reasons. We'll see the capsule hands in a second, those iconic hands that are procedurally generated. Then the ghost hands, the outline hands, and a kind of funky hand, skeleton hand. So you can drive all kinds of interesting models, and then some with arms as well. So the forearm is really important for some experiences.
So the skeletal hand reminded me of the human anatomy. So then maybe we can go in a bit deeper, like what kind of data that we actually get out of the service provider.
Yeah, so developers are probably really interested in this. So how does the data come through from the service? So we have kind of tracking frames, which are kind of a frame of data captured by our kind of tracking service and the camera. And those come in at 90 frames a second, typically, certainly on the Varjo headset they do. And those tracking frames contain position and orientation of the joints, and we track 27 bone hand joints because we include the elbow here as well. And as I said, that's super great for stable experiences. The data itself is organized in quite a kind of anatomically sensible configuration. So you got frames, you got hands within those frames, and then within a hand data structure, you find finger data structures, within those bones, and so on. So you get joints. There's also some additional metadata, which is really useful for people, like metadata for pinch and grab strength, fingertip position, palm position, and velocity. And also you might want to know how long the hand has actually been visible in the scene to that
Yeah,
might be fun.
lots of data available.
Yeah.
Hand tracking. Yeah, that's cool. So yeah, so you shown us already like how to render your hands, that alone already is like so much the immersion of a VR application. But often you want to go further and actually do something with your hands. So can you tell us a little bit what we can do with our hands in VR?
Absolutely. So yeah, you've seen hands, you've seen how easy it is to get hands into your scene and how compelling that is for people. But what are you going to do with those hands once they're there? So one of the easiest things you can do is to retrofit kind of hand tracking to kind of conventional Unity and Unreal UI systems. And we see that being shown in the kind of GIFs that are running at the moment. And we've seen it in the examples as well for sort of VRED. So we provide support for driving these 2D UI systems, and that works in two kind of ways. So we're seeing direct interaction with the UI components, so we're pressing buttons directly with our hands, and that feels kind of supernatural. But then, if you want to maybe control a UI that's further away, you can also use this kind of optional distance activation method, where you see this virtual cursor that's kind of laser projected out onto a UI. And so that's a great way of starting to add hand tracking to an application.
But it's not the only way. But
No.
because this is like the conventional, you would like 2D UIs in 3D environment, but we are humans and we said intuitive gestures or intuitive interaction. So, and I'm using my gestures right now, even my hands and all over the place. So we should be able to use gestures with the hand tracking also, right?
Yeah, absolutely. So when we've all been doing it, I've been watching everybody using hands and gesturing all the time, and yeah, it's why we want to see hands in XR. So you may want to add gesture support to an application, and gestures might be common things that we do, like pinch and grab. So pinch is really common in experiences, or you might want to use hand poses, so a hand in a particular pose to trigger some kind of functionality. But gestures come with a few caveats, right? I've probably pinched my hand several times in explaining this slide. So if you were triggering something off a pinch, you might not want to have that happen accidentally. So it may be you provide some context. So pinch is only active near a certain feature in your user interface or at a particular time. And gestures, there's a trade-off between discoverability. So you might want a gesture that actually isn't really often used, but you would have to teach your user that it's an important thing to do. So yeah, context and discoverability is super important.
And let's see how we can do this pinch gesture in Unity.
Yep. So here we have a Unity project. We'll see how to set up this scene in a little bit. But essentially, I'm going to take the service provider and add some scripts to it. So I've got this pinch detector script. We've got other scripts that we can offer for gestures. And all I'm going to do is, using Unity Event System, I'm hooking it up to the light in the scene, so that we see when the pinch gesture is activated, then the light comes on. When the pinch is deactivated, so your hand comes out of a pinch, then the light goes off. And it's that simple. We haven't had to do any coding or scripting. It's right there in the editor, and we offer lots of other scripts. The last thing we need to do is to have to hook it up to a hand. Is it my left hand or my right hand that's going to use this pinch? So we've just done that. I'm just going to check. Yeah, there it is. It's on the left hand. So when we run, we will see as soon as the pinch happens, the lights will be controlled. And we'll see in a minute how we set up this scene with a cube that you can play around with. So, yeah, there's the hands. I'm playing around with the cube. Suddenly I've done pinches, and I'm triggering the lights. Really quick and simple example, but yeah, you can start setting things up for different hand poses, using our scripts.
It's like magic, right? Like when you do this, like
Yeah.
simple, and then the whole scene changes.
It's like superpowers, yeah.
How about more? Like, what can we do more than the pinching?
So yeah, we're on a path really to a greater fidelity experience for the end user, and kind of things that feel really good and natural. So here we're seeing something called our interaction engine, which is all about taking users' interaction with objects and the virtual world and making it feel really good. And you want to know how to set that up. So here's an example of a physical, more physical user interface called a hand menu, where we've got buttons that actually do press, and they're available in the interaction engine. So physical buttons and sliders. And this direct interaction that we can add with the interaction engine is really nice, really nice. So shall we see how to do it?
Yet another Unity tutorial coming up.
Yeah. So here I'm setting up a scene. So this is pretty common for most people in Unity. We've added a cube, we've added a plane to a Unity project. And right now, this cube, default cube is a meter, right? So we don't want a meter cube because we don't want to pick up a meter cube with our hands. So let's just change the size down to something that's more sensible. So in this example, it's 10 centimeters. So I've just made that, and then I'm just going to do something that makes it stand out a bit. For example, I'll just drag a material onto the cube. So this is fairly normal, right, in terms of we've got hands in the scene, we've got some elements in the scene, but at the moment, when we start this up, you're not going to be able to do anything, and that's not what we want. We want to see how we can change this hand. So here comes our hand, and hey presto, it's going through the cube, nothing's happening. So yeah, we don't like that. So let's see what we can do next. So we're going to add some components to our scene that allows this cube to become something we can really interact with. So we need an interaction manager, and we're going to find that in the prefabs under the interaction engine, drag that into the scene. That sort of sets up the physics properties of the hand, and then you want to identify an object as something you can interact with. So we've got this cube, we've added this interaction behavior to this cube, and suddenly we've got everything we need to start playing around with objects in the scene. So away we go, we press play, and hey presto, we'll get our hands, and suddenly we can play around with the cube with the hands. And yeah, you know, that's a really exciting point to be with, and that's kind of the point where all kinds of ideas start to flow from that. So this is really lovely for the user as well.
Yeah, we get the 2 thumbs up there.
Yeah.
So we have seen all the examples in VR environment, and how would it look like in a mixed reality experience, for example?
Yeah, so, you know, hands, we've spoken about hands in VR as being really kind of enabling and engaging, but they really come to their own in a mixed reality headset, like the Varjo headset. But you know, to get a really compelling experience where you want to see your hand, your real hands, and start to use them as a way of interacting with things, you want some really good hand tracking. And particular properties of the hand tracking that are super important are fast initialization. So bringing your hands in, they're picked up very quickly by the tracking cameras, and suddenly you're tracking, and you know, your hands are there to use instantly. You want low latency. For in this example, you don't want the system's knowledge of where your hand is to be out of date with respect to the real hand, because then you'll start to get disconnects with the experience. You want high pose accuracy, once again, because you want that physical hand and the virtual hand to be in sync. And one thing that I've spoken about earlier is you want an accurate mesh, so you can start to do things like masking, which we'll look at in a minute. So our tracking allows you to distort the mesh, and I think Varjo have similar things, so that, you know, people's hands are in very different shapes and sizes. You want to see their full hand, not cropped in any kind of way. So yeah.
So there's a lot of ways to experiment with these kind of tools that is already out there, which you can just right away start using and implementing. But we have been doing some experiments also at the office. Maybe Jussi can share some more.
Yes, definitely. Yeah, so what you can see here is something, this utility software, free utility software we share called Varjo Lab Tools. So what Varjo Lab Tools does, it basically allows developers to take some of the more advanced features of Varjo devices and bring them even in existing applications without writing a single line of code. So like super easy to add, like for example, a lot of mixed reality features. And the feature in hand we have here is skeletal hand masks. And what that does is that you can see the Volvo here. So that is an existing Unity application that renders the Volvo in mixed reality. But then we have the Varjo Lab Tools running, and it has the skeletal hand masks enabled. So it creates this layer that allows you to see your real hands on top of that virtual Volvo car. And yeah, so this is basically, you don't have to write a single line of code to get access to this, but this is actually super simple to implement yourself. Max, maybe you can show us how it's done.
Yeah, let's build on some examples we've seen earlier and see how we can kind of add XR masking. So the first thing we need to do is set up the Varjo plugin to have pass-through cameras set up. So we've just turned off the opaque setting in the settings, and then we need to add a script to sort of start the mixed reality service. So we see that in the start, Varjo mixed reality start render, and all this is available in the Varjo documentation online, which is super. So suddenly we've set up for pass-through, but how does pass-through actually work? And all it does is it requires an alpha mask to be set up in your view, and then where a pixel is 0000, so alpha RGB, so black, yeah, you will start to see the image. So here I'm setting up a material in Unity, so I can apply it to certain elements in the scene where I want to actually see the real world behind those elements. So I'm applying a kind of a simple shader here, an unlit shader, which all it's going to do, and we'll have a quick look at the shader. It's not super important, but we'll just see there's a line in the shader where I've actually just edited another shader, and I've set it to 000 as a value. So yeah, we've got a shader there, and then, well, how am I actually going to use this shader? So we've seen the ghost hands in the scene earlier on. All I'm going to do is take the prefab, I'm going to unpack that prefab so I can start to make some edits. I then look at the parts of the mesh where there's a Unity material applied, and I'm just going to drag this pass-through material across onto the left hand, and I will just do the same on the right hand. And so this is given as these hands that will actually render as black in the scene, but when passed through, because we've turned it on, we'll suddenly start to see the image behind us. So I'm applying it to the plane, and I've actually set this up an example so that the plane is actually nicely at the level of the table in the real world. For fun, I'm just going to create another cube, because it's one cube is never enough, right? We start Unity, and then suddenly we see this black, right? What's that mean? Well, we applied that pass-through shader. In Unity, it's rendering as black. But as soon as we bring up Varjo base, for example,
Or if you look at the headset.
Yeah, if you're in the headset, you can see through, and we can see that, that mesh hand is tracking the real hand. You see the real hand behind it, rather than that black mesh hand. And I recommend anybody play around with mixed reality, because it's just like being a kid. Playing around with the blocks on the table is really great fun.
It's fun.
And to enable it is quite easy. Like in the Varjo context, you just assign a material that is transparent, and then voila, there you go. You have the mixed reality availability in any kind of mesh that you do have. It could be a floor, it could be a surface, it could be a cockpit, or it could be your hands. Even like your hand mesh could also be a mask, which Max just briefly introduced us. Since we went in the deep dive into the developer issues, so we also would like developers to be developing the applications easier, and we would like to help them a little bit. And recently, the OpenXR has been out there. Maybe we can briefly talk about the OpenXR and how we position ourselves in OpenXR.
Yeah, so OpenXR is something that's very active at the moment in the kind of XR space. And why is it around? Well, developers hate coding something several times, right? You don't want to code for one particular platform and then another particular platform. OpenXR hopes to kind of take away those problems for developers. So it offers a single API that you can code to, and then various platform providers that actually implement that for their platform. OpenXR is an open consortium. People can contribute to it, and one of the things that's been contributed is a hand tracking extension. So this allows you to code to a single hand tracking API, and we provide an implementation of this in our tooling. Our plugins then talk, rather than to LeapC, which is our native API, it talks to the OpenXR extension layer to get hand tracking data. But that could be somebody else's extension as long as they've implemented it correctly. Game engines are really embracing OpenXR, and I think lots of people would recommend that developer community start to look at it and move forwards. And I know it's something that Varjo are also very much behind and have implemented.
Yes, indeed. So Varjo is also really committed to OpenXR. We also agree that it's the way forward in the future. So just makes developers' life so much easier. So for a bit over a year now, I think Varjo has been fully OpenXR conformant runtime. So what that means is that when you have a Varjo-based software installed, you have your Varjo XR3 VR3 devices set up, and you open any OpenXR application, it basically should just work. So you get at least basic stereo rendering and support for motion controllers, and even some more advanced stuff like eye tracking and even hand tracking, because we also implement the mentioned hand tracking extension in our runtime. And we of course have a lot of features that are Varjo specific and like things like foveated rendering and a bunch of mixed reality features. And we are like constantly working on those and improving the support for OpenXR, adding new extensions and contributing to the OpenXR. And working towards like the feature parity with the native SDK. And yeah, well in Unity we, at least in the time being, we still like recommend using the XR plugin, Varjo XR plugin, because that gives you all the supported Varjo features already, and everything just works. But for example, in Unreal Engine, our integration already fully built on top of OpenXR.
Yeah, if I were a developer, then the question would be, I am one, but the question then would be, yes, okay, you guys, you do know everything, and you are talking here and like making this like artistic features here, but then, yeah, but as a developer, how can I do the same things and be fancy at the office, for example, or help to my customers in particular? I know that both Ultraleap and Varjo has super extensive documentation, and specifically Ultraleap has deep documentation in the hand tracking part. Maybe we can talk a bit about the documentation first, the Ultraleap and then the Varjo documentation, to introduce how you can find the information and what you can do with the documentation.
Yeah, so everything we've spoken about, we have good documentation in our plugins, and I'll just briefly say our plugins, Ultraleap release typically every 2 weeks. And we've seen some examples, scenes, which tackle some common implementation scenarios. You might be thinking about, how am I going to do X, Y, or Z? So comprehensive developer-focused documentation is available. Our plugins are also open source on GitHub and MIT licensed, MIT2 licensed. So you can get involved and hopefully build an active community around that. For some scenarios, you have to accept our SDK license agreement. Obviously, if you're a Varjo headset, you've got hand tracking built in. Yeah, and that's when you install the service. But you might be thinking as a developer or even a designer, how am I going to use hand tracking? And we're all on a learning path here, right? There's momentum behind hand tracking in the industry, but we're all trying to work out how we can get best practice. So it's evolving all the time, but we have XR guidelines in our documentation at Ultraleap. And these distill kind of, years and years of experience for designing hand tracking applications for XR into hopefully easy to implement recommendations. So you're thinking about a problem, go look at our XR guidelines, and hopefully you'll see something that's really useful in the way you want to choose to do it. And this is evolving all the time, right? So please go back. We're learning more. Everybody's learning more, So go back and check our documentation again and again. And it covers all the things that we're talking about: gestures, poses, virtual objects, how to do VR training with deliver instructions and menus and UIs. Yeah.
Yeah, same with the Varjo, I guess.
Yes, indeed. Yeah, so first thing you want to do when you get your devices, and or maybe even before you get your devices, you want to go to varjo.com/usecenter and get started. You get all the information, how to get like system requirements and everything you need to support the Varjo device in your PC or workstation, and then how to install everything and set up your devices. Then, of course, when you start developing the applications, you might have different kind of questions in mind. So then just head to developer.varjo.com, and then we have there like a bunch of different documentation, like for general hand tracking documentation. You can see the URL here, and we have documentation for Unity and Unreal, and we walk through like how to set up different things, and also like how to use hand tracking with Watchfish engines and native SDK.
And then the sample scenes, of course.
And the samples, of course, yes. And then we have this Varjo Lab blog where we provide some like expert advice and like a bit more deep dives in some more specific technical topics. So I recommend everyone to check that as well.
It was like so many things coming here and there, like lining up on top of each other. But I think we have seen quite many good ways of making use of hand tracking and how to develop those applications. But maybe now we can take a deep breath and then summarize shortly, briefly, why hand tracking is so important. Maybe Chris can help us with that.
Thank you. Yeah, I appreciate we've covered a lot today, but hopefully it's clear that at Ultraleap we live and breathe hand tracking every day. We are the experts at it. We know how to design for it. We are trying to make that as easy as possible for people. But it's important to remember why hand tracking is important. So hopefully it's clear from today, but it removes that barrier to entry. So we've talked about it before with the VRED experience. We're allowing a C-level executive to come in. They don't have to learn anything. Enabling live representation, so being able to have avatars where maybe you've got multiple people within the same experience, being able to interact with each other in very natural ways. Hand tracking can really help that presence in VR. And then finally, handheld controllers actually remove that level of natural interaction. So being able to bring those hands back in to actually reiterate what you can do in the real world, but in a virtual space is so important. So it's just remembering those three things really, that natural and intuitive interaction is exactly what hand tracking is for.
Yeah, I think it summarizes pretty well what makes the hand tracking super crucial and super important for the VR and XR use cases. I think we are now almost on time with the questions, so we can jump into the Q&A section of the webinar. Again, another reminder, I have the questions over here in my tablet, which I will read out loud soon, but you can still shoot out questions throughout this remaining for 10 to 14 minutes, and we'll try to answer as much as possible. And if we cannot, as I mentioned earlier too, we will publish a blog post with all the answers in detail. So I will start from the topmost question and then continue. The first question comes: how far out are we from having haptics, touch in immersive experiences? Is Ultraleap still working on this side of the immersion?
We are. Haptics is a big part of our future, but that's something we're very much working on in the background, I would say. So watch this space.
Yeah, can't tell much now, but tune to us. Thank you. Yet another question. Do you develop medical content for your technology, or is the model to use your device and find the developer? So basically the question is, do we offer any service, any products that can be ready to be used in the medical context, or is it something that somebody needs to develop? I can quickly answer. So Varjo provides the Varjo and also Ultraleap provides the technology. So you have the hardware, you have the software to run those through, and there are third-party partner software which integrate their software into Varjo, so that the Varjo headsets do work with the off-the-shelf software. There are few in different domains and in different industries. You can find them from Varjo Ready software link in varjo.com, which are off the shelf and ready to use. And there are few medical applications that are there. And if not, if you would like to develop your own, then you can work with a developer or with an agency and develop your own.
I believe we all even have some third-party software that has hand tracking integrated there.
Yes, most probably. Not that I know now, but most probably there must be. So then next one comes from an anonymous person saying that what needs to improve to have hand tracking working accurately and reliably in complete VR-based flight simulators when operating switches and buttons.
Okay.
So that might be so in Unity and Unreal, we have a way of being able to auto-scale the artwork of a hand to the scale of the real-world hand. And that's hugely critical to make sure that we can actually accurately press what you think you're going to press. So in order to be able to do that, that's a huge part of that. But in that sense, using the IR and the hand tracking software, like obviously we're improving this all the time, but this will just get more and more accurate the further we're just developing it.
Yeah, there's of course a certain size of the virtual elements that works seamlessly, and then there's certain sizes, if they're like maybe too small, then you might need to be creative about it, but it's certainly improving with the technology. So let's take the next one. Jonas is asking, we have the name, thank you. How does the IR light tracking works outside in the sun?
Ooh, that is actually a good question. So to be fair, outside in the sun. So I suppose that's something that we may end up seeing more information about with, for example, AR or like mixed reality headsets. So we do work well if you're in a space where the sun is shining into it, but it just depends on how much light is coming in. So it can affect it, but we still do work within that situation.
All right, thank you for the answer. And now we are going again to this medical area with the exoskeleton model representation. So does the exoskeleton model represent the real size of hands, or is the size of hands preset? I have small hands, and tracking gloves always make my hands bigger.
So yeah, we try and estimate as many properties of the hand as possible, and that includes hand sizing. So there, not everything, but there's a lot of information that we gather. So if you turn on the hand scaling or you use procedural hands, those hands should adjust to the size of the user.
Yeah, easy answer. Then the next question comes from Alistair asking, do the LiDAR sensors contribute to the hand tracking, or is it mainly IR? I would say it's mainly IR, and the whole panel agrees that it's mainly IR.
Yes, we have in our Varjo software, we have something called like depth occlusion that we can use to show your hands in mixed reality, but that is like different from this hand tracking.
So that means that you can bring the hands overlaid into the VR environment and see your own hands using the depth occlusion feature, using the LiDAR sensor depth estimation, but that doesn't really, that's not the same as
so
hand
a
tracking.
bit similar case than the hand skeletal masking that we saw, but different technique.
Yes, which you cannot get the hand tracking data using that one, but you can get the hand tracking data using the Ultraleap IR camera processed and delivered algorithm. So let's go to the next one. Does the integration of Ultraleap with Varjo's depth sensor reduce issues with occlusion? Example, if hands are partially occluded, overlapped, they aren't detected, it kind of fails every now and then maybe. We briefly touched to it, so Varjo's depth sensor do not really play together with the Ultraleap's IR cameras and IR sensors. So they are uniquely based on the IR Project IR Lite and then IR cameras and being processed out of there. Any other additions to the question? I think no. So this was pretty similar to the previous question. So they are like completely independent sensors, and they do serve completely independent features. They are not used for the same purposes.
Yep.
Another one, Enrico is asking, Oculus's hand tracking cannot track one hands merging together. Like if one shakes his own hands, for example, can you implement that aspect?
Shake your own hand?
Hand tracking cannot track one's hands merging together. Oh, I think it's like,
that or, because I was like, shake that way. So you can do some like interaction within fingers, but I think the minute you then lose too much of it and it gets like quite close to the palm, and also depends on the angle, then yes, we will end up losing tracking in some points there.
But I think we had some good videos during that to actually show that. We kind of had all these crossing over hands, so you could actually see it continuously working. I think the difference there is the IR illumination. So where we talked about daylight cameras, if it can't see through, there's no light coming through, then it won't actually be able to detect that. But because you're using IR light, it's actually helping counteract the issue that maybe Quest has with its hand tracking.
yeah, it's pretty stable. I mean, you've seen the videos, and you can even try. You could drive pretty easily yourself. So let's jump to the next question. Is it possible to show real hands in the virtual environment? For example, using the XR3's cameras in a completely virtual computer-aided design CAD environment? I can answer quickly maybe, since I read the question. And I feel the confidence value to be closer to 1, so I definitely do that. So yes, that's technically possible. There are 2 ways to do it. The first one would be if these CAD software that you do use have integrated to XR3, then you would be able to just enable it by clicking it in the settings of the application. Or if your CAD application does not provide that kind of an integration, then you can use Varjo Lab Tools, which is free tool developed by Varjo and released by Varjo, and you can access it from developer.varjo.com. That would enable you to just again with a click a checkbox to enable the depth estimation, so that you run the Varjo Lab Tools together with your CAD software, and you would be able to see your hands overlaid on top of the virtual environment. Thank you. This was to myself. Tang is asking, which Varjo headsets have hand tracking? Also, Varjo VR2 or just VR3 and XR3? Justin?
Yes, so we have hand tracking support in Varjo XR3, VR3 and VR2 Pro. So that is the regular VR2 version doesn't have hand tracking.
Very easy answer it was again. Thank you. Tanlady is asking, is a set of hands tracked and recognized so that a third hand brought into the headset's view won't confuse the tracking? For example, now I have the headset and I'm doing these things, and Max is here and he tries to sneak into my view. What happens then?
Yeah, it's pretty good at basically continuing to track the primary user's hand that essentially it picked up first. You know, it is possible to confuse it, but you'd have to try and kind of almost substitute a hand.
I think it's like, basically if you've got the person who's got the headset and those things are within their field of view, like immediately in the foreground, then yeah, generally if Max then had his hands behind like two hands here, it wouldn't really confuse the situation, so we're quite good for that.
Yeah.
Thank you. Another anonymous question asking like a case where there's a person with longer hands. So thinking about users with long hands, what's the tracking range, like min and max? How much does the hand tracking work if my hands are like long?
So we go to like more than a meter. I mean, I suppose how tall could you be? But yes, we do have really good like distance tracking that you can essentially, like if you are a very tall person or someone with really long hands, that works really well. And then I suppose that also kind of links back to what Max was saying about like the accurate mesh, because then once you have applications like that, we would then follow that person's body anatomy.
Thank you. Another question from Selim. He's an academic researcher and he's interested in getting the hand tracking data in conjunction with the eye tracking data from Variobase. Is this possible to do using Variobase, or do I need to develop some application to use the hand tracking data together with the eye tracking data?
Currently, we don't provide the hand tracking data directly from Variobase. So we have a feature in Variobase that allows you to basically record a capture of what the user is seeing along with gaze data from your eyes. So, but we don't have similar, at least for now, we don't have similar functionality for hand tracking. So for that, you would need to use a separate application.
Yeah, that's the answer. What can I say more? Nothing more to say. The last question I think we're going to be getting now is Jay-Z is asking, how does certain clothing affect the reliability of tracking? For example, like the gloves, military sleeves, heavy jackets, etc. Like how does the certain clothing affect?
So everyone's looking at me.
No pressure.
So basically, we have done some internal testing around this, and we can be quite robust against sleeves, because essentially it basically just kind of depends on how far the sleeve is going to go. So if it is like around the wrists, then I know from data that we've gone before, that we're quite good at that. The gloves, it depends on the material, essentially, because it's like, it depends on how it looks. So for example, like black leather gloves, is like, the way that looks in IR, it just means that we're not able to track with those. But I mean, we're continuing to develop, we're continuing to improve, because we want people to be able to kind of use it in any situations. So you'll be seeing more from us around that.
Thank you. I think we have so many more questions, but not enough time to answer all of them here, unfortunately. But as I promised, we will be publishing a blog post about the questions that are here, which I cannot read right now, because these guys here behind the camera, the whole team is saying like, cut it, finish it already. Like, we want to go home. Now, just just to wrap it up, you can contact us to learn more from hello.varjo.com, and to our Ultraleap friends, you can contact from info@ultraleap.com, Varjoleap, info@ultraleap.com. Just say hi, hello, or any questions that you might have. And if you want to have more information about the Varjo products, but specifically, there's a QR code on the right-hand side of the screen, as you see, and you can just scan that one and get the Varjo product book. And on behalf of Varjo, Ultraleap, and these amazing people over here, I would like to thank you all for joining us today into this amazing the Varjo Insight Session webinar, and we look forward to seeing you in the next one. Thank you and bye.
All right.